The B-17 is losing oil at 12,000 feet. The number 3 engine is oozing black streaks across the wing.
In 4 minutes, maybe 5, the propeller will lock up. Then the bomber will drop. The pilot calls for bailout preparations, but the flight engineer is already moving toward the engine with a tin can, a hacksaw blade, and a strip of leather cut from his boot. What occurs in the next 11 minutes will be deemed impossible by every maintenance officer who hears about it until 6 more bombers return using the same method.
The year is 1943. The 8th Air Force is bleeding over Europe. Every raid into Germany costs bombers and crews at rates the planners never anticipated. Fortresses limp home on 2 engines, sometimes only 1. They ditch in the Channel. They crash land in fields across England. The fortunate ones make it back to hardstands where ground crews swarm like surgeons over dying patients. At Bassingbourn, the air smells of oil, hydraulic fluid, and scorched metal. Mechanics labor through the night under hooded lamps. The cold cuts through coveralls. Fingers go numb on wrenches. Mud is everywhere, frozen in the mornings, slick by afternoon.
Bombers return from Bremen or Schweinfurt with holes you could crawl through, wings shredded, tails nearly severed, engines trailing smoke. The ground crews are farmers, garage mechanics, and young men who have learned to repair tractors.
They are not engineers.
They do not possess schematics for every failure. They improvise with what they have because what is available is never enough.
Parts are scarce. Replacements take weeks. So they patch, weld, and cannibalize wrecks to keep others flying.
And every morning before dawn, they watch their work take off into the dark.
Some come back, some do not.
There is no division between those who fly and those who repair.
They are all in it. They all understand the math.
They all count the empty hardstands at dusk.
His name is Technical Sergeant Howard Emery.
He is 24 years old. Before the war, he worked in a machine shop in Akron, Ohio. He repaired industrial presses, steam fittings, and conveyor systems. He learned not from manuals but from observing metal fail, how a bearing wears, how a gasket splits, how pressure finds the weak point and exploits it.
He is quiet.
His crew chief says he listens to engines the way a doctor listens to a heartbeat.
He can detect a misfiring cylinder before the instruments indicate it.
He distinguishes between a valve problem and a fuel issue by the exhaust color. He carries a small notebook in his chest pocket filled with sketches and notes, not official maintenance logs, but personal observations, things he has noticed.
Emery is a flight engineer on AB-17 called Made in America.
His station is between the pilot and the top turret. In flight, he monitors 4 engines, fuel flow, oil pressure, hydraulic systems, and electrical panels. He adjusts fuel mixtures. He transfers fuel to balance weight. He is the one who decides if an engine can be saved or must be shut down. The pilots trust him because he has kept them alive. On the ground, he works alongside the mechanics.
He is not required to. Flight engineers usually rest between missions, but Emery wants to see what breaks and how. He wants to
understand the failures so he can
prevent them at altitude. The crew chief lets him in because Emery does not
pretend to know more than he does.
He asks questions. He watches. He learns. There is a problem no one can solve. Oil lines crack under vibration. They crack
at the fittings where the line meets the
engine block.
The threads strip.
The seals fail. Oil sprays across the NL.
And once it starts, there is no stopping.
It's on the ground, it is a 4-hour repair. In the air, it is a death sentence. The official procedure is to
feather the propeller and shut down the
engine. Most of the time, AB-17 can make it home on 3 engines. But over Germany with fighters and flak, losing
1 engine often means losing another.
And 2 engines on the same wing means you cannot hold altitude. You fall behind the formation, and once you are
alone, the fighters come.
In February of 1943, the 8th Air Force loses 60 bombers in 2 weeks. Many are lost, not to direct combat damage, but to cascading mechanical failures. An oil line cracks. The crew shuts down the engine. They lose speed. They lose altitude. Then something else fails. Then they go down. The engineering staff issues bulletins. They recommend inspection intervals. They order replacement hoses from the States. But the hoses do not arrive, or they arrive
in insufficient numbers, or they are the
wrong specification.
Meanwhile, the mission schedule does not
stop. The bombers fly every day that weather allows, and every day some do not return. Emery sees it happen on a raid to Wilhelmshaven, a fort in the low squadron loses oil pressure at the initial point. They shut down the engine. 10 minutes later, the number 2 engine overheats because the formation is throttling up to evade flak and the remaining engines cannot sustain the load. The bomber drops out. Fighters swarm it. No shoots are seen. Back at Bassingbourn, Emery walks the hard stand
where that crew used to park.
Their names are still stenkled on the nose. Someone will paint over them soon. Someone will assign a new crew. But for now, the space is empty. He thinks about the oil line. The failure is always the same. The threads are fine. The hose is intact, but the joint where they meet cannot handle the vibration. The engine shakes, the fitting loosens, the seal breaks, and once the oil is gone, the engine destroys itself. The official solution is to replace the fittings with a reinforced model. But those fittings are not available. They are on order. They have been on order for months. In the meantime, crews are dying. Emery asks the crew chief if there is any way to reinforce the joint in the field. The crew chief says, no, the threads are machined to a tolerance. You cannot shim them. You cannot wrap them. Any modification would compromise the seal. Further, Emery asks if anyone has tried. The crew chief looks at him. No one has tried, he says. Because it would not work. 3 days later, Emery is in the machine shop at dawn. He has a damaged oil fitting from a scrapped engine. He has a hacksaw, a file, a set of calipers. He is trying to understand why the threads strip. He measures the depth of the threads. He measures the pressure the oil pump generates. He calculates the force on the fitting during normal operation, and then during high power climb, the math is simple. The force exceeds the tensile strength of the seal under sustained vibration. It is not a matter of if the seal fails, it is a matter of when. What he needs is something to distribute the load. Something that sits between the fitting and the housing and absorbs the vibration without blocking the flow. He considers rubber, but rubber degrades under heat and oil. He considers cork, but cork compresses and loses its shape. He considers thin sheet metal, but metal will not conform to the threads. Then he thinks about leather. Leather is used in pump gaskets. It swells slightly when soaked in oil, which helps it seal. It is tough enough to handle vibration, but soft enough to conform to irregular surfaces, and it does not degrade quickly under heat. He cuts a thin washer from a piece of scrap leather. He soaks it in oil for an hour. Then he fits it between the hose and the engine block and tightens the fitting over it. The leather compresses but does not tear. The threads bite cleanly. The seal holds. He takes the assembly to the crew chief. The crew chief looks at it. He asks if Emery has lost his mind. Emery explains the logic. The crew chief says, logic does not matter if it leaks at altitude. If oil sprays into a hotness cell, the whole engine can catch fire. Emery says he knows. He says he wants to test it. The crew chief says no. Emery goes to the squadron maintenance officer. The officer listens for 30 seconds and then cuts him off. Unauthorized modifications are prohibited. If a repair is not in the manual, it does not happen. End of discussion. But Emery cannot let it go. Because he knows what happens when an oil line fails. He has seen it. He has counted the empty beds in the barracks. On March 8, 1943, Maiden America is scheduled for a raid. On run, the target is a Rylard in Brittany. It is considered a lighter mission, less flak than the RAR, fewer
fighters than Berlin, but lighter does
not mean safe. During pre-flight, Emery
notices a small oil seep on the number
3 engine. It is minor, within tolerance. The ground crew says the bomber is cleared to fly, but Emery
knows that small seeps grow into big
ones. He asks if they can replace the fitting. The crew chief says there are no spares. The bomber flies as is. They take off at 6:15. The sky is overcast. They form up over the channel and head south. At 10,000 ft, the number 3 engine starts losing oil pressure. Slowly, a few pounds per minute. The pilot asks Emery for his assessment. Emery says they can make it to target if the leak does not worsen, but if it worsens, they will have to shut down over France. At the
initial point, the leak worsens.
Oil pressure drops from 60 pounds to 40. The pilot asks again. Emery says they have maybe 10 minutes before they have to feather. The bombardier says he needs 6 minutes for the run. The pilot says, make it fast. They drop their bombs. They turn for home. And the oil pressure drops to 25 pounds. The engine is screaming. Now, the temperature gauge climbs into the red. The pilot tells Emery to shut it down, but Emery is thinking about the leather washer. He is thinking about the test he was not allowed to run, and he is thinking that if he shuts down the engine now, they will limp home on 3, and if anything else goes wrong, they will not make it. He tells the pilot to give him 5 minutes. The pilot asks what he is going to do. Emery does not answer. He is already moving aft. He opens the access panel to the engine bay.
The noise is deafening.
The slipstream pulls at his clothes. He can see the oil line vibrating. There is a mist of oil coating the nacelle. The fitting is loose. He can see it wobbling. He has a piece of leather in his pocket. He cut it 2 days ago. He
also has a safety wire and a pair of
pliers. He knows this is insane. He knows that if the leather catches fire, he could lose the whole wing, but he also knows that if he does nothing, the engine is gone anyway. He wraps the safety wire around the fitting to hold it in place. Then he loosens the fitting just enough to slide the leather washer beneath it. His hands are slick with oil. The wind is tearing at him. He tightens the fitting as hard as he can. The leather compresses. The wobble stops. He watches the oil pressure gauge. It stops dropping. It holds at 15 pounds. Then it climbs 20 pounds, 25, 30. The temperature begins to fall. The engine is still running. The propeller is still turning. The seal is holding. He makes his way back to the cockpit. The pilot is staring at the gauges. He asks what Emery did. Emery says he tightened the fitting. The pilot asks how. Emery says he will explain on the ground. They make it back to Bassingbourn. The number 3 engine runs all the way to shutdown. When the ground crew inspects it, they find the leather washer still in place, soaked black with oil, but intact. The crew chief does not say anything. He just looks at Emery. Then he takes the washer and puts it in his toolbox. Word spreads fast. Within a week, 3 other crews report using leather washers to stop oil leaks in flight. One engineer cuts his from a glove. Another uses a Piece of boot lining. All of them work. None of them are officially authorized. The maintenance officer hears about it and orders an investigation. Emery is called in. He explains the principle. The officer says it is a field-expedient, not a solution. Emery says it is a solution until a better one arrives. The officer says he will take it under advisement. 2 weeks later, a technical order is issued. It does not mention Emery. It does not mention leather, but it authorizes the use of secondary gasket reinforcement material for oil line fittings in emergencies. The material specifications include leather, cork, and rubberized canvas. Ground crews are instructed to carry pre-cut washers on all missions. By May, the modification is standard practice across 3 bomb groups. Oil line failures drop by 40%. The change is small, invisible, a washer the size of a quarter, but it keeps engines running, and engines running keep bombers in formation, and bombers in formation come home. No one tracks how many lives are saved by a piece of leather and a sergeant who would not accept the manual as the final word. There is no medal, no condemnation, just a technical order buried in a file cabinet and a quiet understanding among the ground crews that sometimes the solution comes not from engineers in Ohio, but from a man standing in the wind at 12,000 feet with oil on his hands and no other choice. Emery flies 18 more missions. Maiden, America is shot down over Hamburg in July. Emery and 4 others bail out. He spends the rest of the war in Stalag Luft or when he is liberated in 1945, he weighs 120 pounds. He does not talk much about the camp. He does not talk much about the war. After the war, Howard Emery returns to Akron. He goes back to the machine shop. He repairs presses and fittings and conveyor belts. He marries. He raises 2 children. He does not tell them about the leather washer. He does not tell them about the oil line or the engine bay or the 5 minutes over France when he made a choice that defied every regulation he had been trained to follow. His son finds the notebook in a box after Emery dies in 1991. The pages are yellowed. The sketches are faint. There are drawings of fittings and threads and pressure calculations. There are notes in the margins about vibration and load distribution. And on the last page in pencil, a single line: if the engine runs, the crew lives. That is the only specification that matters. It is not a philosophy born of heroism. It is a philosophy born of necessity, of standing in the cold at Bassingorn and watching bombers return with holes in them, and knowing that the difference between survival and death is often something small, a gasket, a fitting, a choice made in the moment when the manual offers nothing and the consequences are absolute. The leather washer modification is forgotten by the official histories. It does not appear in the technical manuals after the war. It is not taught at maintenance schools, but for a few months in 1943, it was the difference, and the men who used it understood. Emery never took credit. He never sought recognition. He did what made sense. He tested it when no one would allow him. He employed it when failure meant death. And when it succeeded, he moved on to the next challenge. That is the type of heroism that does not make headlines, it brings people home. Ultimately, war is not won solely by the brilliant or the daring. It is won by those who see a problem the manual cannot fix and solve it anyway, who trust their hands and their reasoning more than the voices insisting it cannot be done. Those who understand that survival is not merely following orders, but knowing when to bend them. The lesson is not that rules are irrelevant. The lesson is that rules are tools, not gods. And when the tool fails, you reach for something else. Piece of leather, a hacksaw, a refusal to accept that the men beside you must die because the correct part has not arrived. Howard Emery kept 7 bombers alive with a washer cut from his boot. In doing so, he demonstrated what every mechanic, engineer, and determined problem solver already knows:
that the distance between impossible and accomplished is often just one person willing to act.